So hello everyone, this is Akshay and welcome back again to the continuation of our heap sort lecture. So if you have not watched my previous video, do watch it to understand this one, right? So here, let's say we have an input array of 10, 15, 50, 44 and 20, and now we have called a build heap function. We have called a build heap function for to make a max heap, right? To make a max heap. So if you make a max heap here, then definitely 10, 15, 15, 54 and 20 would be our tree structure. Then we will call the heapify for second index, that is starting from this one, that the bottommost rightmost. You know why, right? Please view my previous lecture and you will get to know it. So we'll call from 50 and we'll say that the 50 has none of its right and left children. So there's no point of comparing the largest, right? So we'll move on to the previous index, that is the h of 1. So here in the 15 you will say that the maximum element here is 20, right? So 20 would be swapped with 15. So that's what it's done. And then the maximum index was here, so it will recursively call for this particular index. But for this index now, the node is 15 and there is no left and right children, so recursive call will end here, and then it will go on for heapify of 0th index, right? In the 0th index, that is considering this subtree, right? So you can see that the largest element here is 50, right? Residing on the right hand side, it should be present on the root node, so we will swap it to the root node, and then 50 will come above and then 10 will here, right? Then this was the node of the largest, this was the index of the largest node, right? So we'll recursively call for this index as well again, but then again this will not have, here the value would be 10 and it will not have right and left children, so recursive call will end. And for this particular array, we know the max heap will look like this, right? Max heap will look like this. So now I need to sort it. I need to get the sorted elements. So for this, looking at these just elements, I can definitely say that this will be my last element of my sorted answer, because rest of these elements are less than 50. So what I will do, what the algorithm says is that you swap array of 0 with array of n minus 1 and remove array of, that is n minus 1 will give you as 4, right? Index 4, and remove array 4 from heap. That's what you need to do, right? Okay, so if we do this, let's just look at the dry run. So this tree, this particular thing would be now converted to 15. So this and this would be swapped. So 15 will go above at the head, and 10 will remain same, and 50 will be removed from the tree, right? So again I will call the heapify of the 0th index, correct? Okay, so before proceeding ahead with the dry run, let's just look at the code here now. So the code will look like this, right? We have already covered how the max heap function running. We have already covered how the build heap is running in our previous lecture. In the previous lecture, we have covered the min heap, but here we are covering the max heap. So the only difference is that instead of finding the minimum, we need to find the largest, and then if that largest is not pointing to the root, just recur again for that particular thing, right? So in the heap sort, first you need to do is you need to build heap given with the array elements. That's what we have done, right? And for this I equals to n minus 1 till I greater than equals to 1, we need to swap the first root node with the last node, because we know that the root node will always be greater, and then again we call for the rest of the elements and then we again heapify it, right? ठीक है, तो अब चलते हैं वापस से ड्राई रन पे. तो इस पर्टिकुलर नोड की अगर हम ले heapify कॉल करें, तो it will start from this cell, right? From the bottommost rightmost. But for this particular 10, it will not, heapify will not run. Then it will go for to the next index, that is to this cell, and it will say there is no, what to say, violation here as well, because 20 is largest among its node, right and left. So it will call for now this index, and it will see that among this 15, 20 and 10, 20 is largest, and it will swap its value, right? So what would be our next tree? So it would be 20, 15, 10 and 4, right? And again the array elements here will look like this. So 50 is now fixed, right? 50 is now fixed to the last element. We just need to handle the rest of the elements, that is nothing but 15, 20, 10 and 4, correct? And here, as you can see, that this will be our max heap for this particular tree, for this particular input, correct? So now here the array elements would be looking like 20, 15, 10, 4, and the last element is, as usually it is fixed, so let us write it with 50, correct? Now we will again call, in this particular max heap, we know that this is the largest element, right? So we will again swap this 20 with 4, right? So how the tree will look like? So we will swap the 20 with 4, and the tree will look like 4, 15, 10, and we will remove the last node as well, right? So we will remove this last node. So that means our array is looking like, now we have two elements as fixed elements, 50, 20, right? And for the rest of these elements we need to still process it, right? So it would be 4, 15, and 10, correct? So now we will again call the Heapify function here. So it will start from the second last level with the rightmost mode. So it will call the Heapify from here, right? So we will call the Heapify at 0 index. So will there be any changes? Right? It will compare the right child, the next child, the left child, and the root. इसमें largest कौन सा है 15, so it will get swapped with this 4, right? तो यहाँ पे क्या हो जाएगा हमारे पास, the next max heap will be there as 15, and then 4, and then 10, correct? Then again what we will do, again we will swap the 15, the root node, with the last, right? With the last. So that means this, if we look at this array, what the array will look like, again the 50 and 20 were fixed, so the elements here which is not fixed is 15, 4, and 10, right? You need to swap the first with the last in each and every step. So this will be swapped with this, and we will remove the last node, right? So what the heap will look like now, it will look like 10 and 4, and the array here, now three elements would be fixed. Now we will be getting three elements in our answer as of now. So 20, and then 15, and we still need to check for rest of the elements, that is 10. So let me write it a different color, that is 10 and 4, right? Again the max heapify function will run for which one, heapify of 0. So heapify of 0 would be called, and then the heap will remain unchanged, because in this for this thing 0 and with the ये node जो है हमारा 10, that is our the maximum node, right? तो यहाँ पे कोई changes नहीं होगा, and then again we will do the thing that swapping the root node with the last node value and removing the last node, right? So here the array will look like, so we will swap it this here and we will terminate it, right? So it will look like just 4 is there, right? 4 is the single node that is present there. So now what the values are fixed here, the values fixed here is, first of all 50 was there, and then 20 was there, and 15. Now 10 will also be get swapped, right? So 10 will also be get fixed now, and the only element remaining is just 4, right? Okay, so for this 4, what will happen, that since this is one single node, there is no what to say, need to call a heapify function. एक node के लिए आप क्या ही कर लो heapify function में, right? So that is why in this loop you will see that we have run this build heap with this heap sort function till n minus 1 to greater than equals to 1, and not for 0, right? And as you can see that this is your required answer, that is 4, 10, 15, 20, 50. This is your final answer that is getting in the sorted format. Okay, so let us now analyze the time complexity, and then we'll move to the code editor, right? So definitely this build heap we have already discussed in the previous lecture, it takes O of n time. This for loop will take again O of n time, and this heapify function in the worst case it takes the log n, right? So that means n plus n log n. So that means the time complexity we can derive it as n log n, and space complexity what we can say as space complexity to be nothing but log n. And where this log n is coming from, as we discussed in the previous lecture, this heapify function takes the space complexity of log n, right? And that's all. That is only the recursive stack space that we will be using here. No additional structure we are using. So that would be, if we ignore the recursive stack space, then we can directly say that it is O of 1. But since we have to consider the recursive stack space as well, so it would be log n. So again, the time complexity is n log n and space complexity is log n. That is what we have covered our heap sort. So we have completed our 2 videos covering the max heapify, what is binary heap. Let me summarize it. So we have covered the max heapify, then we have covered build heap, that takes the O of n complexity, and then in the heap sort function how the things changes, right? Okay, so that is it. Let us move to the code editor, and it is highly recommended for you guys to please try run for some other problems and then move back to your code editor. Okay guys, so this is the code. Let me give you a very quick walkthrough. So we have a build for heap function where it goes from n minus 2 minus 1 to I greater than equals to 2. We have already discussed this thing, why it is greater than equals to 0. Then we have a heap sort function which is running from n minus 1 to greater than 0. You can directly write it as greater than equals to 1 as well. We need to swap the root node with the last node, and we need to remove the last node, and we call the Heapify function for rest of the from 0 to n minus 2. And then again in the third iteration from 0 to n minus 3 till we have reached to our first node. Yep. We have already covered this, how we are covering the max Heapify. We just have declared a max index and then the left index and the right index of the children. Using this two, we are just finding that which is the largest among the root child, left child, and the right child, right? And if the index of the root element is not the index of the max element, then we have to swap the max element to the element with the largest one, right? That's what we are doing, and then we are again calling the Heapify function for the node which for the place which it was having the max element, right? मैंने आपको बहुत अच्छे ड्राइंग करके समझाया है अपने प्रीवियस वीडियो में भी और इस वीडियो में भी, तो प्लीज वॉच इट. आई होप आपको समझ में आ भी रहा होगा. And yes, that is it. Let us compile and run. While it is compiling and running, we have already discussed the time complexity as well. It is O of NlogN and then O of logN for the recursive stack space. So that is it. Let us hit the submit button, then we'll see the C++ code and we'll end this video. Great, the solution has been successfully submitted. So my attempts were to, if you see that my first submission was done on 2021, the time of my placement season. So I hope you are also preparing for your season. Great, and you can see that, yep. So let me show you the C++ code now. Okay, so that is the C++ code, the same code that we have mentioned in the Java. All the source code links will be present in the description. You can take help from there. Let us hit the submit button for this C++ code as well, and then we can end this video. Great, all the test cases have been passed successfully, and we have successfully covered the heap sort with all the requirements of the max Heapify, of the build heap, and how it is happening in the sorting one, right? So let us end this video here. We'll meet again in the next video of this playlist. Till then, keep learning, keep growing. Bye bye, and take care, guys.